This lesson is the last one to talk about how to solve a quadratic. We looked at ones where you have no b value. We looked at ones where there was no c value. We looked at ones that you can graph. This technique is actually pretty cool because it works for any quadratic no matter what the form. However, it has to be put in the form ax squared plus bx plus c equals 0, meaning that it has to equal 0. Everything has to be on one side in order to use this technique, but it's actually really cool. Now, you might be freaking out right now when you look at this formula, but I want you to understand that eventually this formula is just going to become second nature to you. And it's just going to be like the formula for the Pythagorean theorem or the formula for the volume of a rectangular prism, right? Or the area of a triangle. You're going to be really comfortable with this, so don't freak out. So example 1 wants us to use the quadratic formula to solve 2x squared minus 5x plus 3 equals 0. So the first thing that we check is that it equals 0, which it does. And then we're going to crank through this crazy looking formula. Okay, so the first thing that we do is we just write out what A, B, and C are. Now back in chapter 8, we needed A and B, and now we need C. So A is 2, B is negative 5, and C is 3. So all you do is you just take them and you just plug them in this formula. So x equals negative 5, which is actually positive 5. Plus or minus, we talked about the plus minus symbol. The big square root, meaning that this whole thing inside is being square rooted. Negative 5 squared minus 4 times a, which is 2, times c, which is 3. I'm just going to extend that radical sign. All over 2 times 2. So the first step is to find A, B, and C. The second step is to just plug them in the formula. Always do those 2 steps. Don't skip anything. Now you just follow order of operations. So the first thing that I'm going to do is what's underneath the radical, the grouping symbol. And be careful, negative 5 squared is positive 25. 4 times 2 times 3 is 24. All divided by 4. So I did a couple simplification steps in one, but I simplified it a little. Now I'm going to go up here to my second step, which is just keep simplifying. I'm going to get x equals 5 plus or minus the square root of 1, all divided by 4. So that's obviously the square root of 1 is 1. Now the reason that you have plus minus is because we know that we're going to have 2 answers. So the 2 answers are either 5 plus 1 over 4 or 5 minus 1 over 4. So 5 plus 1 is 6 over 4, which is 3 halves or 1.5. And then that gives me 4 over 4, which is the number 1. So the 2 answers for x are 3 halves and 1. There you go. We didn't need to factor, we didn't need to graph, we didn't need to figure out, half of b, we didn't need to square root, any of that. We just crank it right through the formula. Let's look at another example. The number of northern Rocky Mountain wolf breeding pairs X since year 1990 can be modeled by this crazy looking function. When were the breeding pairs 35? So Y stands for the number of breeding pairs. So what I'm doing is I'm going to put 35 in for Y. Okay. Now, I definitely wouldn't want to use any of my techniques because I have decimals as coefficients. It's really annoying looking. So this is a perfect example for the quadratic formula. So the quadratic formula only works if it equals 0, so let's bring that 35 over. So I'll get 0.20x squared plus 1.8x minus 38. Now I can use the quadratic formula. A is 0.20, B is 1.8, and C is negative 38. You see how if I didn't bring that 35 over, my C would have been wrong. So now let's just crank it through the formula. You can't see it on the screen anymore, but I can write it out. So it's going to be x equals negative b, so that's going to be negative 1.8, plus or minus the square root of 1.8 squared minus 4 times 0.20 times negative 38. I always need to end up bringing my square root symbol out because I never make it long enough. I don't know, that's weird. Over 2 times 0.20. All right, calculators powered up. Here we go. X equals negative 1.8 plus or minus the square root. 1.8 squared is 3.24. 4 times 0.20 times negative 38 is negative 30.4. So it's minus negative, so I'm going to total plus. Minus is part of the formula, so if you get a negative, you have to add it. All divided by 2 times 0.20, which is 0.4. All right, we just kind of keep crunching our numbers. So we get x equals negative 1.8 plus or minus the square root of 3.24 plus 30.4 is 33.64, all divided by 0.4. Good thing I have infinite space. Okay, so I get x equals negative 1.8 plus or minus the square root of 33.64 is 5.8 over 0.4. So now I have two possible answers, negative 1.8 plus 5.8 over 0.4, or negative 1.8 minus 5.8 over 0.4. So let me calculate that. Negative 1.8 plus 5.8 divided by 0.4 is 10. And negative 1.8 minus 5.8 divided by 0.4 is negative 19. So my possible values of x are negative 19 and 10. Now let me go back up to the story and recall what it was about. X stood for the number of years since 1990. So I can't have negative years, so bye-bye to the negative number, which means that the x value is 10, but that's not the answer because it says what year, when were there 35 breeding pairs. So 10 years since 1990 is going to be 2000. So the answer, long story, is 2000. The year 2000. All right, now thing in the quadratic formula, b squared minus 4ac, which is the expression that's underneath the radical sign, that is what we call the discriminant. Now, because the discriminant is under the radical sign, you can use it to determine the number of roots, which we know are the x-intercepts and the solutions. The way that you would use it is you would look at three potential things that the discriminant could be. It could be positive, negative, or 0. So if you have a positive discriminant, meaning that the b squared minus 4ac number is greater than 0, then you would be able to take the square root. So you get a graph like this. You'd get two real solutions. If the discriminant is 0, then we would get a situation where we can only get one square root, right? The square root of 0 is just the number 0. So that would give me one real solution. If the discriminant is negative, then you can't take the square root because you can't take the square root of a negative number, and that would be a situation where there are no solutions or no x-intercepts. So sometimes you just want to figure out how many answers there are, not necessarily what they are, and that's where the discriminant comes in. So if we want to figure out the number of solutions, just how many there are, not what they are, we just want to use that b squared minus 4ac part. We don't need to do that whole fraction formula and all that. So we have to first do the same thing we did last time, is we have to make sure that it equals 0, and we have to get the a, b, and c numbers. So a is 1, b is 8, and c is -3. So now the only part that we're doing is b squared minus 4ac. We're not doing anything else. We're not even square rooting it. So that's going to be 8 squared minus 4 times 1 times -3. So that is 64 plus 12. Well, that's going to be 76, so that's positive, which means that there are going to be 2 solutions, because you can take the square root of a positive number. In letter B, we have to move the 6x over first, so we'll get 9x squared minus 6x plus 1 equals 0. Now I can use the ABC. So A is 9, B is now -6, and C is 1. So b squared minus 4ac gives me -6 squared minus 4 times 9 times 1. Don't forget that -6 squared is positive 36. 4 times 9 times 1 is 36, so that's 36 minus 36, which is 0. Since there's only one square root of 0, this means that there is one solution. All right, why don't you try example 4 on your own? All right, I got -63 as my discriminant. I had to first just say that it equals 0, and then instead of saying no solutions, because the question asked about the number of intercepts, I just wanted to use that language in the answer. Now this chart we're going to go over when I see you. It just goes over the different types and when you would use it. If you have any questions, write them down and ask me when you see me next.